Welcome to Project Management. In this video, I will talk about how to estimate project time and cost. Estimating project time and cost is the foundation for project planning and control. Estimating is the process of forecasting or approximating the time and cost of completing project deliverables. It's carried out at the early stage of the project. Estimating is important for project management. It supports good decision-making. It provides information of how long the project should take and its cost. It determines whether the project is worth doing. The estimation can serve as a baseline to calculate the cash flow needs and determine how well the project is progressing. All project stakeholders prefer accurate cost and time estimates, but they also understand the inherent uncertainty in all projects. Inaccurate estimates lead to false expectations and consumer dissatisfaction. Accuracy is improved with great effort. That is, spending more money and time doing the estimating will increase the accuracy. But is it really worth it? Project estimating becomes a trade-off, balancing the benefits of better accuracy against the effort for securing increased accuracy. Many factors may influence the quality of time and cost estimates. Projects with long horizons are very difficult to estimate. Estimates of current events can be close to 100% accurate, but are reduced for more distant events. A complex project is more difficult to estimate accurately than a simple project. Accuracy of estimates depends on the skills of the people involved that make the estimates. If they are very familiar with the task they are estimating, the accuracy could be very high. Organizational and project structure will have a great impact on the quality of estimates. As we mentioned in a previous video, one of the major advantages of a dedicated project team is the speed gained from concentrated focus and localized project decisions. This speed comes at an additional cost of allocating personnel full-time. Conversely, projects operating in a matrix environment may reduce costs by more efficiently sharing personnel across projects, but may take longer to complete, since attention is divided and coordination demands are higher. Padding may also affect the estimating accuracy. For example, if I'm asked how long it takes me to drive from Binghamton to the JFK airport in New York City, I may give an average time of 4 hours, assuming a 50% chance of getting there. If I'm asked the fastest I could possibly get there, I might reduce the driving time to 3.5 hours. Finally, if I'm asked how long the drive would take if I absolutely had to be there, it is likely I would increase the estimate to say 5 hours to ensure not being late due to traffic or bad weather. In work situations where you are asked for time and cost estimates, most of us are inclined to add a little padding to increase the probability and reduce the risk of being late. If everyone at all levels of the project adds a little padding to reduce risk, the project duration and cost are seriously overstated. This phenomenon causes some managers to make a 10 to 15% cut in the estimates. But the next time the game is played, the person doing the estimating will pad the estimate to 20% or more. Therefore, such games will reduce the quality of realistic estimates. Organizational culture will influence the quality of the estimate as well. In an organization with a prevailing belief that detailed estimating is not worth the effort, the accuracy will be low. Other organizations with the belief that accurate estimates are critical to effective project management will most likely go for high-quality estimates. Other factors like equipment downtime, holidays, favorable, unfavorable weather, or natural disasters, etc., also play a role and somehow affects the quality of estimating project time and cost. A manager can follow 7 guidelines to develop time, cost, and resource estimates. First, use people, especially team members who are familiar with the tasks to do the estimation to ensure the quality. Also, if these people are not consulted, it would be difficult to hold them responsible later for failure to achieve the estimated time and cost made by themselves. Second, it's better to consult multiple people and use a weighted average to do the estimation than just solely rely on one person's estimate. Third, if the normal workday is 8 hours, the time estimate should be based on an 8-hour day. Similarly, if the normal workday has 2 shifts, the time estimate should be based on a 16-hour workday. Fourth, in practice, the use of workdays is the dominant choice for expressing task duration. However, in small or mini projects, hours or even minutes probably would be more appropriate as a time unit. Fifth, each task's time estimate should be considered independently of other activities in the work breakdown structure. Sixth, top management or the project management office will usually create an extra fund for contingencies that can be used to cover unforeseen events. Therefore, project managers should not pad their estimates at this stage. Last, the project manager can provide risk assessment of the estimates to avoid surprises to stakeholders. A simple breakdown by optimistic, most likely, and pessimistic for each task could provide valuable information regarding time and cost. There are some bad practices in estimating project time and cost that project managers should avoid. One statement is, rough order of magnitude is good enough. Spending time on detailed estimating wastes money. $1 million and $9 million are in the same order of magnitude, but they are 9 times different. We also mentioned that accurate estimates are critical to the success of a project. Rough estimates or no estimates at all may lead to project failure, which wastes even more money than obtaining accurate estimates. Another statement is, time is everything. Our survival depends on getting there first. Forget about the estimating and just do it. Just because you have tight schedule doesn't mean that you should skip the estimating overall. If done well, it will determine whether the project is worth doing. You will regret it if that information is missing and later you find out you are in a project that will take forever to finish because budget or resource limitations. The third statement is, the project is internal. We don't need to bother with estimates. Or the project is small. We don't need to worry about cost. Internal and small projects may still involve some level of complexity. If an internal project involves quite some innovative technologies that are not commonly seen in an organization, the estimation will still be needed to serve as a base to plan for the cash flow needs at different stages to lower the risks. Inaccurate estimates may lead to significant cost and time overruns. A study on Harvard Business Review shows that 1 in 6 projects have a 70% time overrun and a 200% cost overrun. Watch these videos to see 3 real examples. The first one is Hawaii real project that involved significant delays and cost overruns. In the second project, FBI looks after a new Detroit jail project for reasons behind significant cost overruns. In the third example, you will see that cost overruns are common in Olympics projects. Estimating methods are frequently classified as top-down methods and bottom-up methods. Top-down methods are also called the macro methods. They are usually done by senior management using experience to determine the duration and total cost of a project. The top-down methods usually require little knowledge of the detailed processes used to complete the project. Bottom-up estimates are typically performed by the people who are doing the actual work. They are also called micro methods. Micro estimating is usually more accurate than macro estimating. There are some conditions that suggest when one approach is preferred over the other. If the results are used for strategic decision-making, or it's an internal small project, then top-down estimates are sufficient to provide approximate time and cost. If a lot of uncertainties are involved or the scope is likely to change as project progresses, it's impossible to secure accurate predictions. Then the top-down methods are a good choice to provide some ballpark numbers. For projects that need high accuracy, or the customer is interested in the details on the cost and time estimates, the bottom-up methods are preferred. Another condition that favors bottom-up methods is in a fixed-price contract. The customer only pays for the project or product at a fixed price. Accurate cost estimates are essential for the project bid and to justify whether the project is worth doing. Estimating is usually not a one-shot effort. Good practice is to follow these 5 steps. First, make rough top-down estimates. This is because sometimes much of the information needed to derive accurate time and cost estimates is not available in the initial phase of the project. For example, the design is not finalized yet. Then, as the project progresses, we will develop the work breakdown structure and organizational breakdown structure. Tasks, work packages, and personnel responsibilities in the work breakdown structure and organizational breakdown structure are clearly defined. Next, make more accurate bottom-up estimates. After that, develop the project budgets and schedules for the work packages. Finally, reconcile the differences between the top-down and bottom-up estimates. The simplest top-down method is probably the consensus method. It uses the pooled experience of senior and middle managers to estimate the total project duration and cost. This method is easy to implement, but sometimes the estimates could be significantly off the mark because little detailed information is gathered. Another commonly used top-down method is the ratio method, or sometimes referred to as the parametric method. For example, we can use a number of square feet to estimate the time and cost for building a house. A house of 2,000 square feet may cost $150 per square foot. So the total cost is 2,000 square feet times $150 per square foot equals $300,000. Also, based on past experience, it takes approximately 180 days to build a house of this size. The third top-down method we will introduce is called the Apportion method. It is used when projects closely follow past projects in features and costs. Given good historical data, estimates can be made quickly with little effort and reasonable accuracy. This is a commonly used method in projects that are relatively standard but have some small variation or customization. Here is an example of the Apportion method. It allocates project costs using the work breakdown structure of a software development project. We assume that the total project cost is known and estimate to be $100,000. It has 4 major deliverables or development phases. Based on historical data of similar projects, design will account for 20% of the total cost, that is $20,000. Programming 30%, or $30,000, and so on. The design phase has 2 work packages. Each accounts for 10% of the total project cost. Work packages of other phases can also be achieved this way. The function point method is a very popular top-down method in the software industry. Software development projects are frequently estimated using the weighted number of function points. The weighted number of function points can be counted using the number of inputs, number of outputs, number of inquiries, number of data files, and number of interfaces. Then we can convert the function points to the number of person-month. For example, one programmer can finish 5 function points per month. If you want to learn more about software engineering project management, I highly recommend this book titled The Mythical Man-Month. Let's see an example. This software development project can be decomposed into 10 inputs, 5 outputs, 15 inquiries, 20 data files, and 10 interfaces. The complexity of inputs is low. Each input function is equivalent to 2 function points. So 10 inputs is equivalent to 20 function points. The data files are quite complex. Each data file is equivalent to 9 function points. So in total, they are equivalent to 180 function points, and so on. After we have calculated the function points of all these elements, we add them together and the entire project is equivalent to 350 function points. Now let's answer some questions. The first question is, if one person-month represents 5 function points, how many person-months will be needed to finish this project? To solve this problem, we divide 350 function points by 5 and get 70 person-months. Next question is, if 10 programmers are available, how long will it take them to finish this project? We assume the total number of person-months is divisible. That means, if it needs 1 programmer to finish the project in 70 months, then it will need 10 programmers who work together to finish the project in just 7 months. The third question, if each programmer's monthly salary is $8,000, what is the total estimated cost of the project? The total cost is equal to the number of programmers, 10, times the number of months of the project, 7, times monthly salary for each programmer, $8,000. Assuming there is no other cost, the total cost of the project is $560,000. The last top-down method we will introduce is called the learning curve method. A learning curve is also called an improvement curve or an experience curve. This method is used for projects that require the same task or product to be repeated several times. The time to perform a task improves with repetition. This phenomenon is especially true for tasks that are labor-intensive. Each time the output quantity doubles, the unit labor hours are reduced at a constant rate. The keyword here is doubles. The learning rate may vary from 60%, representing a 40% improvement, to 100%, representing no improvement at all. Let's see an example. A manufacturer has a new contract for 8 prototype units. A total of 100 labor hours were required for the first unit. Past experience indicated that on similar types of units, the learning rate was 80%. The question is, how many labor hours will be needed for the 8th unit? Let's make a table to answer the question. For the first unit, we know that it will consume 100 labor hours. For the second unit, because the quantity doubles from 1 to 2, we only need 80% of the time at the first unit. That is 100 hours times 80%, and we get 80 hours. For the fourth unit, the quantity doubles again from 2 to 4. We only need 80% of the time at the second unit. That is 80% to the power of 2. And we need 64 labor hours to produce the fourth unit. Similarly, for the 8th unit, the quantity doubles another time. We need 80% of the time as the 4th unit. That is 80% to the power of 3. We need 51.2 labor hours. And this is the answer to the question. For a unit number that is not a power of 2, we can use this mathematical relation on the right to find out the amount of labor hours needed to produce that unit. In this equation, n is the unit number, 2 for the 2nd unit, 3 for the 3rd unit, etc. T1 is the amount of time to produce the 1st unit. Tn is the amount of time to produce unit n. R is the learning rate. Ln means the natural logarithm. In the table here, for the 3rd unit, n equals 3. The rate is equal to 3 to the power of ln 0.8 over ln 2. It equals 70.2%. Therefore, the time needed to produce the 3rd unit is 70.2 labor hours. For other units, the calculation procedure is the same. After we get the amount of time for each unit, we can calculate the total or cumulative time for manufacturing all the 8 units. We just add them all together, and the result is 534.6 labor hours. We can also calculate the average time for making a unit, which is the total time divided by 8. It gives us 66.8 labor hours per unit. This is greatly reduced from 100 hours if there were no learning improvement. The top-down methods make time and cost estimates at the project level. In comparison, the bottom-up methods are concerned about the task or work package level time and cost estimation. We will briefly mention some of the bottom-up methods here, but will not go into detail. If a project is similar to past projects, the cost and schedule from past projects can be used as a starting point for the new project. Differences in the new project can be noted, and past times and costs will be adjusted to reflect these differences. This method is called the template method. The parametric technique such as cost per square foot used for top-down estimates can be applied to specific tasks and work packages in the bottom-up method. Another bottom-up method is range estimation. It works best when work packages have significant uncertainty associated with the time and cost to complete. In such cases, it requires 3 estimates: low, average, and high. The low to high give a range which the average estimate will fall within. Phase estimating is a method that is a hybrid of the top-down and bottom-up methods, and is used when an unusual amount of uncertainty surrounds a project, and it's impractical or impossible to estimate time and cost for the project. Phase estimating is also called life cycle estimating. This approach begins with a top-down estimate for the project, and then refines estimates for the phases of the project as it is implemented. For example, a detailed estimate is developed for the immediate phase 1, and a macro estimate is made for the remaining phases of the project. After phase 1 is done, another detailed estimate is developed for the immediate phase 2, and a macro estimate is made for the remaining phases of the project. This pattern will repeat until all the phases have been completed. One drawback of the hybrid estimating method is that the customer who is paying for the project often perceives phase estimating as a blank check, because costs and schedules are not firm over most of the project lifecycle. So before applying this method, the project manager must get the approval of the customer. This is a summary of the differences between top-down and bottom-up estimates. The top-down methods are best for the feasibility study or conceptual design to get some rough numbers about the time and cost of the project. Because the level of effort involved for estimating is low, the preparation cost is low, typically between 0.1% and 0.3% of the total project cost. But the accuracy is also low, between negative 20% and positive 60% of the target. Commonly used top-down methods are consensus, ratio or parametric, apportion, function point, and learning curve. The bottom-up methods are best for budgeting, scheduling, and resource allocation purposes that requires accurate estimates of time and cost. Because the level of effort involved for estimating is high, the preparation cost is high, typically between 0.3% to 1% of the total project cost. But the accuracy is high, between negative 10% and positive 30% of the target. Commonly used bottom-up methods are template, parametric, range estimates starting at the work package level. A project manager should carefully weigh the pros and cons of these methods before finally picking one that will work for their project. When building the work breakdown structure for a project, the level of detail varies with the complexity of the project, the need for control, the project size, cost, duration, and other factors. Excessive detail is costly because it forces a focus on individual lowest level of sub-deliverables rather than on high-level deliverables of the project. And it also creates unproductive paperwork. If the level of the work breakdown structure is increased by 1, the number of cost accounts may increase geometrically. This will also increase the estimating work during the planning phase. Insufficient detail is also costly because of its lack of focus on goals and may waste effort on non-essential activities. The project manager needs to strike a balance. A frequent rule of thumb used by practicing project managers says that a task duration should not exceed 5 workdays or at the most 10 workdays. Suppose the time estimate of a task is 40 workdays. It may be better to divide the task into 7 or 8 smaller tasks for control purposes. This is because if one of the smaller tasks gets behind because of problems or a poor time estimate, it will be possible to take corrective actions quickly and avoid delaying other following tasks in the project. If the single task of 40 workdays is used, it is possible that no corrective actions would be taken until day 40. When estimating the cost, we need to consider all kinds of costs found in a project. Typical cost components are the direct cost, the direct overhead, as well as the general and administrative overhead, or sometimes called the indirect cost. The direct cost includes those that are clearly chargeable to a specific work package. They represent real cash outflows and must be paid as the project progresses. Examples are labor cost, material cost, equipment cost, etc. The direct overhead is a cost related to resources of the organization that are being used in the project. The overhead rates are usually a ratio of the dollar value of the resources used. They include fringe benefits, space, supplies, energy, etc. General and administrative overhead, or the indirect cost, is organizational cost across all projects such as advertising, accounting, and senior management. Such costs are not directly linked to work packages of a specific project. They are proportionally assigned to each project. Overhead costs are usually calculated using a certain percentage of the total direct cost. When it's time to bid for a project, all these costs must be considered together with the profit margin before offering the total bid. This is an example. The estimated total direct cost is $80,000 for a project. The direct overhead is $20,000, which is 25% of the direct cost. Add them up, the total direct cost is $100,000. The general and administrative cost, or indirect cost, is $20,000, which is 20% of the total direct cost. So the total direct and indirect cost is $120,000. The project office has an expected profit of $24,000, which is 20% of the total cost. The total bid is therefore $144,000. Perceptions of costs and budgets vary depending on the users. The project office will commit funds months before they are used. The project manager will plan when the budgeted cost is expected to occur and monitor when the budgeted cost is actually charged. Such information will be used to measure project schedule and cost variances. We will talk about this in another video. Even with the best estimating efforts, it may be necessary to revise time and cost estimates based on relevant information prior to establishing a baseline schedule and budget. There could be multiple reasons for adjusting the estimates. First, we assume that each task is to be done independently when we do the estimation. But in reality, there could be hidden interaction costs that are not counted toward the estimates. Second, resource shortages in the form of people, equipment, or materials can cause errors in estimates because they deviate the project from normal conditions that are used to estimate time and cost. Third, things can go wrong on projects. Extreme weather conditions and accidents, for example, will make the original estimates invalid. Fourth, as it gets further and further into the project, a project manager may receive requests of making changes from customers. When the project scope is affected, the adjustments in time and cost estimates need to follow. Lastly, research indicates that there is a tendency in people to overestimate how quickly they can get things done and underestimate how long it will take them to complete tasks. The inaccurate estimates due to this overly optimistic attitude needs to be corrected. Also, there is growing evidence that some project promoters underestimate the costs of the projects and overestimate project benefits in order to win approval. This is particularly true for large-scale public work projects. We will show you some examples later. The best way to improve estimates is to collect and archive data on past project estimates and actual numbers. The project manager then makes any necessary adjustments concerning differences in the materials, labor, equipment, and other factors. Items not found in the database can be added to the project. After the project is done, the information will be added to the database for future references. It's extremely difficult to achieve accurate time and cost estimates for mega projects. A mega project is a large-scale, complex venture that typically costs $1 billion or more, takes many years to complete, and involves multiple private and public stakeholders. Examples are high-speed railways, airports, healthcare reform, development of new aircrafts, and the Olympics. They all tend to go way over budget and fall far behind schedule. Mega projects tend to cost much more than expected, but under-deliver on benefits. For example, when Denver International Airport opened in 1995, it costed 200% more than the budget and 2 years behind the original schedule. It realized only 55% of the forecasted traffic. The channel, which is the 31-mile tunnel between France and UK, was 80% over the budget. Traffic revenues were only 50% of the predicted value. In addition to the sheer complexity of long planning horizon, researchers suggest that project promoters use deception to promote projects not for public good, but for personal political or economic gain. Some mega projects are white elephants. They used to be valuable, but now they are burdensome. The owner cannot easily dispose of them, and the maintaining cost is way out of the proportion of its value. The name White Elephant came from the story of kings of Siam, now Thailand. A king would often make a present of a white elephant to countries who had fallen out of favor of the king. The so-called great honor would ruin the recipients by forcing them to absorb the costs of taking care of the animal. Many people think the Olympics have become white elephants. Watch these two videos. One is titled Olympic Venues, Then vs. Now. The other is titled What Rio Doesn't Want the World to See. Okay, in this video, we talked about how to estimate project time and cost for project planning and control using the top-down and bottom-up methods. We also talked about mega projects, white elephants, and the challenges associated with estimating for these projects. This is Wang, and I'll see you in the next video.